So we talked about counting methods last time. Now we're going to be using this permutations and combinations thing. Now, permutation is when the order does matter. Okay, the order does matter. Combination means order does not matter. Okay, what does it mean? Like, let's say that I have permutation. I have 7p7. Let's say I have 7 books. Okay, so there's 7 books. So 1, 2, 3, 4, 5, 6, 7. And I'm gonna arrange 7 of them. Okay. From left to right. 1, 2, 3, 4, 5, 6, 7. I'm gonna arrange 7 of them from left to right. For my first book, how many choices do I have? I have 7. Okay. For my second book, I got 6 choices. Okay, I take one out. And then you got like, well, I got 5 choices. And then for the next book, I got 4 choices. And then I have 3 choices. I have 2 choices. And then I have 1 choice. I'll multiply that out. 7 times 6 times 5 times 4 times 3 times 2 times 1. What did that give you? 7 times 6 times 5 times 4 times 3 times 2 times 1. My case, it gave me 5,040. Okay, that's not that bad. Now, here for question number 6, let's say I have 8 books. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, but I'm only gonna do 3 in order. I'm gonna only line up 3 books from left to right. So how many choices do I have on the first one? Well, I got 8 choices. Good. Take 1 book out. How many choices do you have for the second one? I got 7 choices. Good. Take 1 book out. And then I got 6 choices. And then just multiply that out. 8 times 7 times 6. In my case, he gave me 336. Now, there gotta be formulas for this because this is not that bad. But what if I told you you have 200 books and you're gonna line up the first 100? Whoa, that's a lot. That's a lot of writing, right? I'm not gonna do such thing. But however, we should be able to solve that. What I'm going to be doing, let me introduce you to the number factorial, what factorial means. 3 factorial is basically going from 3 multiplication all the way to 1. So 3 times 2 times 1. If I said 5 factorial, it's going to be 5 times 4 times 3 times 2 times 1. Okay, 7 factorial. It's basically what we see here on the list. 7 times 6 times 5 times 4 times 3 times 2 times 1. Cool. What I'm going to be doing, let me do this in red. For my formula, I choose my first number, and I'm going to write this as 7 factorial. At the bottom, because I'm going to do a fraction, at the bottom, I'm going to subtract these. The first one minus the second one. 7 minus 7. That's going to give me 0 factorial. Now, I cannot divide by 0, but I can divide by 0 factorial. 0 factorial is 1. 1 factorial is also 1. So this is 7 factorial divided by 1. And there you see your answer, 5,040. Now, you guys are like, well, could I have done this the same here in number 6? Yes. You could have gone, choose the first number, 8 factorial, over, then you subtract the 2 numbers. 8 minus 3 is 5 factorial. So when you think about this, you're like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. If I cancel these numbers, 8 times 7 times 6. Remember what we did earlier? Now, could I have written this differently? Yes. Let's see, 8 factorial over 5 factorial. I could have written this as 8 times 7 times 6 times 5 factorial. Wait, why did I do factorial there? Because remember that 5 means 5 times 4 times 3 times 2 times 1. At the bottom, I have a 5 factorial. That way I can just cancel them out. Instead of canceling the group one by one, cancel the whole group. So 8 times 7 times 6. So that's what we do permutation. And that's when order does matter. Now, combination. That's when order does not matter. Right? For example, you guys are choosing players for a team. It will matter if you guys are choosing, okay, let's choose the goalie first. Let's say I'm looking at soccer. The goalie first. Then the second player is going to be the forward. The third player is going to be the defender. Okay, that one order matters. So that's a permutation. But now what if order does not matter? You guys are just going to choose 5 people because you guys are 10 people. Let's say 10 people are playing soccer. So you guys are going to say, well, 5v5. So you're going to choose 5 people and order does not matter because we're just going to play it all alone. So order doesn't matter. That's when we use combinations. So I'm going to do this. I'm going to start it kind of how we did permutations. I'm going to do 22 factorial over 2 factorial. Remember the 2 because I subtracted 22 minus 20. However, because order does not matter, I'm going to add at the bottom of my fraction, I'm going to add 20 factorial. And that comes from this number, the second value. Because there's a number at the bottom, that means I'm dividing. My number should be a little bit smaller. So I have to do 22 factorial divided by 2 factorial and 20 factorial. So let's see how does this look like. I can go 22 times 21 times 20 factorial. Why 20 factorial? Because I don't really want to write 20 times 19 times 18 times 17 all the way to 1. I stop at 20 factorial because I have a 20 factorial at the bottom already. So I'm going to cancel those groups out. Instead of going 20, 19, 18, and then canceling number by number, boom, I cancel all at once. However, I still got this 2 factorial here. So 2 times 1. So I'm going to go 22 times 21 divided by 2. My answer here is 231. Okay. Take a look at number 18. I'm going to go 11 factorial over 5 factorial because 11 minus 6 gave me 5. However, I have a 6 factorial as well. Okay, my 11 factorial, I'm going to write this as 11 times 10 times 9 times 8 times 7 times 6 factorial. I have another 6 factorial at the bottom, so I just want to cancel the whole group. However, there's still a 5 factorial, so there's 5 times 4 times 3 times 2 times 1. Multiply the top first, then multiply the bottom. So that way you simplify the top, simplify the bottom. So what do I mean with simplified? For the top, just go 11 times 10 times 9 times 8 times 7. So let me do 11 times 10 times 9 times 8 times 7. So it gives me 55,440. And now here at the bottom, I have 5 times 4 times 3 times 2 times 1, which is 120. Now divide those two numbers, and I get 462. Now, what is this deal here at the bottom? Find the number of unique permutations of the letters in each word. So I have some words. Let's say I could rearrange it to form different words. How many words can we write? I'm not gonna list them all, seriously. Like one of them could be level. Right? I'm not looking at how many words. Let me rephrase that. I'm not looking at how many words. I'm looking at how many ordered I can write this. I could write this as EELLV. May not be a word, but are the same letters. I just rearranged them. I could have write this as EVELL. I could do many arrangements, right? So here it's asking how many arrangements can you write? Unique arrangements, unique permutations. So if I switch the E's, I get the same word, right? The same letter. So that one doesn't count. Okay, so how are we going to do this? First of all, how many letters are there? 5 of them, right? So let me write this as 5 factorial over. Are there any letters that repeat? Yeah, the L's, right? I see the L's repeating. How many L's do we have? 2. Okay, so let me write 2 factorial. Are there any other letters that repeat? Yeah, the E's. Okay, how many E's do we have? 2. Right. There's 1, 2. So let me write this as 2 factorial. Are there any other letters that repeat? No. Okay. So on the top, I have 5 times 4 times 3 times 2 factorial. There is a 2 factorial at the bottom. Talking about this 2 factorial. They cancel out. However, there's still a 2 factorial at the bottom here. So I have 5 times 4 times 3. That's 60. At the bottom, I have 2 times 1, 2. 60 divided by 2 is 30. Nice. Let's take a look at, definitely, I was not going to make the list, right? There's 30 different arrangements. Forget that. I was not going to do that. Let's take a look at number 10. The word Canada. If you were to rearrange the letters, how many different rearrangements do we have? Okay, let's take a look. How many letters are there together? All of them. There's 6 of them, right? So I'm going to write 6 factorial. Okay. Are there any letters that repeat? The A's, right? There's 1, 2, 3 A's. So 3 factorial. Are there any other letters that repeat? No. Okay. So I'm going to say on the top, I have 6 times 5 times 4 times 3 factorial, because I have a 3 factorial at the bottom. So I want them to cancel out. So my answer is 6 times 5 times 4. So that means I could have write this 120 different ways. Yeah, definitely. I'm not going to do that by hand.